Good morning, student. I am continuing from the same unit, that is general principle and processes of isolation of elements. And so far we have covered up to the concentration. In this part I am going to explain about the extraction of crude metal from concentrated ore, that is reduction of ores. So you can see here that the extraction of crude metal from the concentrated ore involves the following two steps. The first step is the conversion of the ore into metallic oxide, and second step is reduction of the metallic oxide to the free metals. These are the two steps involved in extraction of crude metal from concentrated ore. Conversion of ore into metallic oxide. The ore of the metals are usually in the form of hydrated oxides, carbonates, and sulfides. Depending on the nature of the ore, two methods are used for conversion into oxide. Number one is the calcination. Calcination is used for the ore containing oxide, hydroxide, or carbonates of the respective metals. So, how we can define the calcination? The process of heating the concentrated ore below its fusion temperature in absence of air is known as calcination of ore. Heating the concentrated ore below its fusion temperature in absence of air is known as calcination of ore. It is carried out in the reverberatory furnace, and during the calcination, moisture is driven out, carbonates lose carbon dioxide, and the material becomes porous and can be easily reduced. See, for example, bauxite. It's a chief ore of aluminium. Formula is Al2O3.2H2O. It is a bauxite ore, which on heating gives alumina Al2O3 and evolves two molecules of water, 2H2O. Likewise, calamine, which is the ore of zinc. It is carbonate ore of zinc, which on heating get converted into zinc oxide and evolves carbon dioxide gas. Likewise, limestone. It is the carbonate ore of calcium, which on heating gives calcium oxide and carbon dioxide. Limonite. It is the ore of iron. Formula is Fe2O3.3H2O, which on heating gives ferric oxide Fe2O3 plus 3H2O. So this is what is calcination. Calcination is normally done for the hydroxide ores or ore containing water molecules or carbonates. These on heating, what happens on heating below the fusion temperature of the metal in absence of air, that during the calcination the moisture is driven out, carbonates get converted into the carbon dioxide, and the material becomes porous and can be easily reduced. Calcination is done in the reverberatory furnace. Reverberatory furnace. Second one, calcination, and the second one for conversion of ore into metallic oxide is roasting. The process of conversion of sulfide ore into oxide ore in presence of O2 is known as roasting. And like calcination, roasting is also carried out in a reverberatory furnace. During calcination, non-metals get converted into their respective oxide and disappear in the air. Sulfide ores get converted into the oxide ores, evolving SO2 gas, and after the roasting, the ore becomes porous and dry. For example, ZNS, zinc blende, which on heating in presence of air gives zinc oxide and evolves sulfur dioxide gas. Likewise, copper glass, Cu2s, on heating in the presence of oxygen gives cuprous oxide and SO2 gas. And roasting is carried out only for the sulfide ores. Do remember, for hydroxide ores, carbonate ores, sulfite ore, we normally carry calcination, and for roasting we use roasting only for the sulfide ores.